Hello everyone, welcome back. And this is Teacher ChiYew from Tech Academy, and I'll be going through the Primary 4 Competition DMD Week 4 solutions. Now, so in this case, we have 7 questions for the day, so let us begin on the first question. So, first question, calculate and leave your answer as a fraction in its simplest form. So we have a 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, all the way to 10 squared minus 1 as a numerator. And for the denominator, we actually have 2 squared, 3 squared, 4 squared, all the way to 10 squared. So all of them are multiplied together, and we are looking out for the fraction in simplest form. So usually for these kind of questions, there's actually a very easy approach for it. And the idea stems from this factorization property that we actually have. A square minus b square equal to a plus b, a minus b. So if you guys look at the numerator closely, we can actually apply this property. Why? Because 1 square is equal to 1. So we can simply replace it in that form. Now, if we are going to do that, what are we going to obtain? We are going to obtain, say, 2 plus 1, 2 minus 1 divided by 2 squared, multiplied by 3 plus 1, 3 minus 1 over 3 squared, multiplied by 4 plus 1, 4 minus 1 over 4 squared, all the way to 10 plus 1, 10 minus 1, divided by 10 squared. And that's the idea. That's the main idea. And then simplifying this a little bit more, we actually obtain 3 times 1 over 2 squared multiplied by 4 times 2 over 3 squared times 5 times 3 over 4 squared times all the way to 11 times 9 over 10 squared. So now notice a little bit of things over here. There's actually a lot of cancellation that's going on over here. So the 2's will cancel out to become 1. And then we notice that the 3's will all disappear. The 1 by default. And we can kind of see a pattern that's going on over here. It's kind of a crossing-like pattern. So we are going to cancel out a lot of things all the way. By following this pattern over here, we will end up with just half times 11 out of 10, which finally gives us the final answer, 11 out of 20. So in this case over here, while this one over here is a secondary school topic, while this one over here is a little bit of secondary school topic, factorization, one of the standard factorization formulas that many secondary school students need to understand, it is still tested in Math Olympiad. And this one is a very nice property that we usually use. And usually, these kind of questions, it will only make sense when we actually when we actually find innovative and smart ways to cancel things out. Alright, so without further ado, let us move on to question 2. So question 2 in this case over here, we need to calculate and leave your answer as a fraction in its simplest form. So 1 plus 2 plus 3 all the way to plus 10. We have 11 plus 12 plus 13 all the way to plus 20. Now, so one very nice formula that we need is for the arithmetic progression, right? So the sum, or denoted as Sn, would just be the number of terms divided by 2, the first term plus the last term. So in this case over here, it's very nice. So we notice that the top part is also an arithmetic progression, but some of you guys might call it as a Gaussian sum in this case, but actually all of them are just a part of the arithmetic progression because the denominator needs to be simplified in that way. So applying this formula, we get really nice formulas out. We get 10 times 11 over 2 for the top part, and then we know that the bottom has also 10 terms divided by 2. The starting term is 11, ending term is 20. So you notice that the 2's are going to cancel out. And through some basic simplification, alright, so in this case we are just going to simplify this a little bit more, and we will actually obtain 11 plus 20 which will give us the final answer of 11 out of 31. And that's the main idea. That's the main idea that I would like to share everyone over here. So sometimes understanding Gaussian sums is also good, but we also need to understand that for more general pattern, number pattern questions, finding the sum, we will need to use the AP. And that's the main idea for question 2. So without further ado, let us move on to question 3. So ABC are 603, 939, and 393 respectively. Given a number x, the remainder of A divided by x is twice that of the remainder of B when divided by x. The remainder of B divided by x is twice the remainder of C divided by x. So we have quite a bit of very important information that is over here. So we know what is A, B, and C, but we need to figure out x this time. And that is where we should use the concept of modulo to help us out. So in this case over here, we can see that 603 gives us a remainder. Suppose it's R1 modulo x. We have 939 giving us half R1 modulo x. Alright, and then we have 393 giving us 1/4 R1 modulo x. Right, because it's half. B divided by x is twice that of the remainder of C divided by x. That's the main idea. So now if we now what we are trying to do is to try and get rid of R1. By this case over here, we need to simplify a little bit further. 939 is congruent to half R1 modulo x. We need to multiply them by 2. Get 1878 being congruent to R1 modulo x. And for 393, congruent to 1/4 R1, we multiply by 4. We get 1572 modulo R1 congruent to R1 modulo x. Now, so we have quite a few equations hanging around over here right now. In this case over here, we can do a little bit of subtraction to remove. So in this case over here, 1878, we are going to take 1878 minus away 603, which will get 1275, which is congruent to 0 modulo x. So there's no remainder when 1275 is divided by x. And in the same fashion, I'll take 1572 minus 603. Alright, it's going to give us 969. 0 modulo x. Aha, so that means x must be a factor. X this time around must be a factor of both 1275 and 969. So we are going to look for the highest common factor this time around. So 1275 is equal to 3 times 5 squared times 17. And 969 is just going to be 3 times 17 times 19. How do we get the highest common factor? To find the highest common factor, we just need to compare the powers and take the lower power in this case. So 3 and 3, there is one common factor over here. 5, 2, and 5, 0. Right, this is 5 power 0. We're going to take 5, 0. So it's just going to be 1. For 17, we have 1. So we are just going to take 17. So in this case over here, the highest common factor would just be 51. So now, what would that mean? X can be 1, 3, 17, or 51. So, of course, these two cases are impossible. Alright, I'll leave that to you to verify through this over here, using this guys over here. Now, in this case over here, if we are to check 51, it is also wrong as well. When we check 51, when we divide 51, we will notice that the remainder doesn't match what is stated. So this one is wrong as well. So finally, we actually obtain x equal to 17 as our final answer. Now in this case over here, this question is actually very challenging in the sense that we need to understand the concept of modulo and remainders, as well as being able to find the highest common factor. That's the main concept that we are trying to emphasize in this question. Alright, so I hope everyone can understand this. Alright, now without further ado, let's move on to question 4. Now the school competition, the average score of the school is 8 points. the average number of girls, score of girls, is 10% higher than the average score of boys. And the number of boys participating is 10% higher than the number of girls participating. Find the average score of boys. Well, in this case over here, it kind of hits us that we need to use a little bit of algebra approach to solve this. But a lot of people are very tempted. Let X be a number of boys, let Y be a number of girls. But you guys will actually hit a roadblock. In this case over here, it will be very difficult if you just let them be the numbers because we have averages over here. So why not change our approach? Let's take a look at this approach instead. Let X be the number, be the average score of boys. Alright, and then we can let Y be the number of girls. So the average score of girls must be equal to 1.1x. And then the number of boys will just be 1.1y. So we know the total average, we know the average score of the school is 80 points. So we're going to use that. We're going to find the total score for the left side and the right side. Now in this case over here, because the total score is just the total score of boys plus the total score of girls, we can do that as well. So we notice that the total score for boys is actually 1.1xy as well. Because the number of boys is 1.1y, average score of boys is x. That will be the total score of boys. And the number of girls times the average score of number of girls times the average score of girls will also be 1.1xy, which is the total score of girls. And what about the total score for the school itself? So it's going to be 8 plus y plus 1.1y. Right, because there are y girls and there are 1.1y boys. Now in this case over here, we notice y appears everywhere, in every single term. And that's good news for us actually. So if I were to simplify this a little bit, I hope everyone can see this. 88, 2.1y. Right, notice that y occurs everywhere. We can get rid of that. So I get 2.2x equal to 88 times 2.1. This will give us the score of boys, which is 84. The average score of boys in this case will just be 84. And that's the main idea behind this question over here. So I hope everyone can understand this one. It really boils down to how we set our variables and understanding the concept of average. So without further ado, let's move on to question 5. So with this very messy expression over here, we have to find 6 times 6 times 6 times 6 times 6, a lot of 6, 7 6s, and 9 times 9 times 9 times 9, a lot of 9s, 7 9s. So in this kind of idea, we can actually try out small numbers. So what do I mean by try out small numbers? We can take a look at 6 times 9 first, which is 54. Alright, so doesn't look like there's a pattern. Let us try out 66 times 99. So maybe this was a little tough to multiply, but what we can do is to apply a trick. This is asking for 66 sets of 99s. This is equivalent to 66 sets of hundreds minus away 66, which then we will obtain 6,600 minus 66, so we get 6534. Alright, there's some form of a pattern. Let's try it out again using the same method. Alright, if we are going to apply the same method, we're going to get this. And hey, there seems to be a pattern going on over here. We notice that it is always 1 less 6 over there. And then we follow by 5. And there are 2 3s this time round. And then 1 4. So we can kind of get the idea. If we are going to do this pattern, we are just going to get, if we follow this pattern very closely, we are just going to get 6 6s, right? 1 2 3 4 5 6, followed by 5. and then 6 trees, and then followed by 1 4. And that is the main idea. So following the pattern is especially important. We can start small. The whole idea about this question is to start small, and then hopefully we can get a solution out of it. We can identify some sort of a nice regular pattern, and then afterwards we can solve this question with ease. Now, let us move on to question 6. So a dairy farm produces 220 kg of milk a day, and the helper uses exactly 20 buckets to fill up the milk. Then the buckets come in small and large sizes. The large bucket can hold 12 kg of milk, and the small bucket can hold 8 kg of milk. Find the number of big buckets used in this case. So one very good thing about this question is that it's a very standard PSLE-like question. But at the same time, as this is a competition course, we are going to introduce a little bit more tools to help you guys out, namely simultaneous equations. So in this case over here, we can let x be the number of small buckets, and let y be the number of large buckets. So let's take a look at some little conditions, some equations that we can form out of here. Well, we know that the helper uses exactly 20 buckets. So naturally, we have x plus y equal to 20. And what about second condition over here? The dairy farm produces 220 kg of milk a day. So you fill up the milk, we need them to add up to 220. So the small ones are able to fill 8x kg of milk. And the large ones are able to hold 12y kg of milk. And what must these add up to? It must add up to 220. That's the main concept behind this. And now we're going to understand the concept of substitution. We're going to shift the way y to the other side. Let x equal to 20 minus y. And hey, if you look at this very carefully, if x is 20 minus y and there's an x over here, we can essentially replace this x with 20 minus y. So, and that's what we are going to do. So remembering our expansion idea over here, expand using a rainbow method. 160 minus 8y plus 12y or 220. And then this will be 4y equal to 60. Which tell me that y is equal to 15. And so the number of big buckets used this time round is actually just 15. That's the main idea behind question 6. So hopefully everyone can understand this question. Now let's move on to our last question for our DMD. So there's a triangular lawn in the park. The length of the three sides of the lawn is 60 meters, 72 meters, and 96 meters. If you plant one tree every 6 meters around the lawn, how many trees do you need? So we have a triangular like lawn, maybe something like this. Teacher Chew is I'm not very sure how to draw the exact triangle because that will invoke this thing called the cosine rule. Right, so we have something that looks a little bit like this. We are going to find how many trees do we need. We need a tree every 6 meters apart, right? Every 6 meters apart. In terms of the distance around the lawn, right? So maybe there's a 6 here, and then maybe there's another 6 here. Well, we can just add up the numbers, you realize. That is essentially the idea, because you realize it's actually over here in this case, it's really nice. All these are multiples of 6. So all we have to do is to take 60 plus 96 plus 72. We get 228. And then after it's 228 divided by 6, we get 38 trees. Oh my. Trees. And that is pretty much about it for this question over here. So with that is pretty much about it for the week 4 DMD. And hopefully I look forward to seeing everyone for the week 5 DMD, which is coming up very soon. And as usual, we are going to go through the solutions for week 5 DMD next week as well. Until then, thank you very much for watching these solutions over here, and hopefully to see you guys next week.